if you remember from yesterday, I mentioned in terms of 5.1 and 5.5, we have this new or not the new material in terms of the rule for your exponent. Reminder that this is only the rule for exponent. And I put it in this way a little bit different from yesterday in the sense that I want to point out that number 1, number 2, and number 3, this is the most important rule that you will deal with in your problem, or most or all of your problem will involve one of these 3 rules. And reminder, rule number 1 is for this slide, rule number 1 is the product rule. Is basically tell you that if you multiply the 2 exponent, or not multiply exponent, if you multiply the same base, which is in this case, my base is x. If you multiply the same base, you need to add the exponent. And vice versa, if you divide the same base, you need to subtract the exponent. And lastly, number 3, if you have a base raised to a power and raise it to another power, we call a power rule. If you have a power raised to the power, all we need to do is take the 2 power and multiply them. So this is the 3 most important rule that you will see that for every single problem from here on out, when we deal with the exponent rule, you will have to apply one of these 3. Or in some problem, you have all 3 of them, okay? And when we mention in terms of number 4 and number 5, I just mentioned that this is the extension of 1 and 2. If you look at number 4 is just the addition of number 3 with the number 1. So if you multiply and the base are not the same, as you can see, x and y are not the same, all we're doing is we distributive our exponent in. We just basically, if the x times y, which is the product, all we did was we distributive our exponent to the x and distributive our exponent to the y. So the product raised to the power versus number 5, the product raised it to the quotient, raised it to the power. Similarly, the x and y, because they are different base, you cannot subtract them. All you do is you distributive the exponent in. So basically, number 4, the rule number 4 is basically we combine rule number 1 with number 3, and vice versa. Rule number 5, we combine rule number 2 with number 3. You will see, or we will explore that in a bit. The number 6 and number 7 here is just a no facts, right? It's the facts that anything raised to the 1 power, and if something that does not have an exponent is assumed to be 1, right? So anything raised to the 1 power is equal to itself, and anything raised to the 0 power is equal to 1. So those are the 2 facts that we have. And you will see, and by the end of today, you will see that this is probably the most difficult rule to apply, or this is the most difficult rule to comprehend, in the sense that because whatever you just learned, this rule, the negative rule of exponent, and by the way, the negative rule of exponent is in 5.5. So this is the only rule that in 5.5 is a negative exponent. And if you remember from yesterday, the negative exponent, I told you guys that as long as you have a negative exponent, it's basically tell you that you need to move that negative exponent. If the negative exponent is on the numerator, we need to move it to the denominator and make it a positive. Vice versa, if the negative exponent is on the denominator, we need to move it to the numerator and make it a positive. So that's the idea of negative exponent, is just basically tell you that it does not belong where it at, right? Wherever your negative exponent is. I forgot to erase this item. Wherever your negative exponent is at, that's what you need to do, is to move it to a different location. So let's take a look at this example here, and I give you guys a small cheat sheet in terms of the rule on the side, but one thing I want to point out, ladies and gentlemen, is in order for you to be successfully understand the material of chapter 5, you need to know those rules. And that's the hardest part, is all of the rule that you learned before is still apply. The negative rule, the addition rule, all of the rules before still apply. Now we just add on another 8 rules that we need to remember. Okay, so let's take a look at example 1. They ask you to simplify and write your solution in positive exponent. So we have this 4 problem here, and when you look at this problem, one thing I tell my student is, for this particular section, is the hardest for me to teach you guys how to do this problem, because there are many ways that you can attack a problem. There is no fixed way, right? There's no item that I say you have to do this first, this first, this first. One thing I tell my student is, if you remember the rule, you look at the problem and you ask yourself, what rule do you have? Whatever rule that you can apply, you apply to that rule, and whatever the leftover rule, you keep on applying until you cannot apply anymore. Okay, so but I will try to keep it as consistent as possible so that you can see, if you look at the problem, you know what to do. So for example A, or example 1A, as you can see, this is the easy example. Why is easy example? Because there's only one rule that apply with this problem, and we know that this is the product rule, right? Which is the product rule tell us that if we multiply the same base, in this case, we know that my base is A, that is the same base, and if the same base, all they tell you to do is add the exponent, right? We kept the base and add the exponent. In this case, we know that we have A, raise it to the 13th power, and because the 13th power is positive, we are done, right? So that's what we have, is we have the product rule, and the product rule tell us that we need to add the exponent. And you know, you can do this, you can say A plus 5 plus A, and instead of write it on the bottom. But like I say, you want to show me the work, so at least if something wrong on your test, I can go in and look at your scratch work, right? So if you look at B, you can see that there are 2 rules here, right? We have a product rule on the numerator, and we have a division, which is a quotient rule. So it doesn't matter which rule you apply, but for me, if there is something on the same, meaning on the same numerator, on the same denominator, I want to get rid of those items first. And if we have this item, do you agree that I can simplify this item here in the sense that C to the 4 times C to the 7, what do I do to the exponent? Well, I know that it's multiplication. The rule tell me that all I need to do is add the exponent. And if I add the exponent now, my new problem will be C to the 11 all over C to the 8. Again, the denominator, I don't have anything in terms of that. So given this structure, now I'm done with the product. Now we can see that we have a quotient rule left, right? We have a quotient rule, and the quotient rule tell me that I need to take the numerator, the exponent, minus the exponent of the denominator. So in the sense, we can see that 11 minus 8 to give me C to the, not 4, but 3, right? 11 minus 8 will give me 3, which give me the answer C to the 3rd power. And as you can see, there's nothing else we can simplify. C to the 3rd power, and that's it. Agree? There's no other rule. And because the exponent is positive, I got the answer. And that's your goal, and that's your objective, ladies and gentlemen, is when you look at one problem, what rule can you apply? Okay. So first of all, before we do C and D, question in how to solve A, or how to solve, not solve, and we're not solving anything, how to simplify A and simplify B. So if you don't have question C, this is what we have is, if you look at this item, and this is the one time I will write it this way, After this, you will not see me write it this way. But again, for me, if there is a parenthesis, and just like before, as long as there's a parenthesis, to get rid of the parenthesis, we know that we have to distributive our item in. In this case, we distributive the power. And if you see this thing here, this is technically what we're doing is, we mentioned this yesterday. Technically, all you're doing is you put the 2 where the y to the 6, and the 2 where the y to the 2nd, right? So again, for me, I know some of you will say, well, Mr. Tran, I do it a little bit different. And again, it's the same. I will show you the other way that some of you probably did it. And like I mentioned, I want to keep it consistent as possible. So for me to keep it consistent, if there's a parenthesis, I want to distribute that exponent in. And if I distribute the exponent in, as you can see, basically 6 raised to the 2nd power, that's telling me that I need to take the 6 times the 12, which I mean not times the 12, times the 2 to give me 12, and 3 times the 2 to give me y to the 6. Agree? And again, same thing go. We still have multiplication here, it haven't changed. And if you can see that we have a multiplication, do you agree that now if I have a multiplication, all I need to do is take the 12 plus the 6 to give me y to the 18? And that is your answer, because there's nothing that you can simplify further, because that's the one thing you have, right? And some of you guys will say, well, Mr. Tran, I did not do that, and I still haven't the right answer. Well, that's fine, because some of you guys probably say, from here, let me change to different color. From here, do you agree that inside there's a product? And if there's a product, I can add them together. And if I add them together, do you agree that 3 plus 6 will give me 9? And if I simplify that, and now do you agree that 9 times 2 still give me y to the 18? And as you can see, y to the 18 on top is the same. So, and that's where I mentioned to you guys that it's hard for me to tell you what to do first. If I have 10 of you guys, there are 9 different ways that you can do a problem. And it, and is very flexible in terms that no matter what rule you apply first, as long as you apply the right rule and keep the right rule, you will have the right answer. Okay, so everybody see the different way we can approach this item. Question with C. And for me, like I say, for me, it's weird. When I do it in my head, I do it differently, because I've been doing it a lot and I know which one is a shortcut. But because I try to keep it consistent, I try to make you guys see at least one way to solve it. So for me, I like to keep it very consistent in terms that if we have a parenthesis, I want to get rid of the parenthesis first. I know we can simplify on inside, but for me, for this D, about see this D here, we have a parenthesis and we have a multiplication, and then we have a division. For me, I want to keep it consistent to you guys. I'll give you guys a consistency. For me, I want to distribute the 3 into the numerator. Why can I not distribute to the denominator? Reminder that the parenthesis is only illustrate or only associate with the numerator, and that's why I cannot distribute the 3 to the 13. Okay, so if I distribute this thing here, we can see that 2 times 3. Do you agree that 2 times 3 will give me 6, and 2 times 3 to give me 6, and 8 times 3 to give me 24, all over z to the 13. Everybody agree that 2 times 3 will give me z to the 6, and 8 times 3 to give me 24. And if you distribute this thing here, now you can see that this problem D, after you do the distribution, is just the same as problem D up here, right? We have, right, we eliminate the exponent. Now all we got is something like this on top, which give me, all I need to do is I can add the exponent to the numerator. On the numerator, I can add the exponent. to give me z to the 6 plus 24 is 30 all over z to the 13. Agree? The product tell me to add the exponent, and reminder, I emphasize that you add the exponent. You know, your rule for multiplication 3 times 4 is the same as 12. This is only applied for the exponent. Okay, don't change the rule and 3 times 4 and give me 7. You know, a lot of people focus on this rule and then they mistake the regular multiplication rule. This is only applied for exponent. So once we have this, do you agree that now I can do, give me 1 second, I can do z 30 minus 13. And 30 minus 13, do you agree that I have z to the 17? And there's nothing else I can simplify. And this will be my answer. So question here in terms of A, B, C, and D. And like I mentioned to you guys, if in order for you to be good with this problem, if right now, if you are shaky and you still don't see where to start, in order to be good with this problem, you need to know your rule. If you know your rule, all of this problem will be very, very doable. So question with A, B, C, or D here before we move to a little bit monster problem, a bigger problem. All right. So let's take a look at this item here. What is the difference between D versus E? Hopefully you see the biggest difference between D versus E is E, my parenthesis is a big parenthesis. And because it's a big parenthesis, in order for me to get rid of this 2, everybody see that I need to distribute the 2 to the 4, the 2 to the 3, and the 2 to the 5. Meaning because this big parenthesis, the 2 is associated with every single item inside your parenthesis. Okay, and if you look at this item here, this item we have in D, the parenthesis is a small parenthesis, is only the numerator, and that is why I only distributed on the numerator in D and not to the denominator. Everybody see the parenthesis in D is only the numerator versus the parenthesis in E, you have the whole item there. Okay, so make sure you know that we have a big parenthesis versus a small parenthesis. And in this case, do you agree that 4 times 2 will give me 8, 3 times 2 to give me 6, and 5 times 2 to give me 10? Agree? And after you do this distribution, this is the same as example B earlier, in the sense that I need to add this item here to give me y to the 14 all over y to the 10. Agree? And now what do I do? Well, 14 minus 10, I know that 14 minus 10 to give me, you all know 14 minus 10 to give you 4, which my answer is y to the 4. Okay, so yes, the problem look monstrous, right? It look humongous or it look big, but you know, you take one step at a time. Get rid of the parenthesis by distributive them in, get rid of the multiplication by add the exponent, and get rid of the division by subtract the exponent. Okay, and again, whoever say, Mr. Tran, I did not do that, I do a little bit different, and again, it's fine. And just to challenge you guys or to make you guys think in another way, everybody see right here, whoever saw it this way, if you want to do it, is perfectly fine. Everybody see that in here, we can add this item here. We can add this to give me y to the 7 all over y to the 5th. And again, I have not done any of the exponents, so I keep it, right? And once you have that, do you agree that inside here, we can subtract this item to give you y to the 2nd, because 7 minus 5 to give you to the 2nd power. And once you have that, we know that the power raised to the power, all we need to do is multiply the power, which is 2 multiplied to 2 to give you 4, and magically, right? Magically, no matter how you apply it, you can see that these two answers are the same. Okay, and that's the hardest part, is to tell you what to apply first. Know your rule and see what you have and apply. And some of you say, well, I apply differently. Yes, as long as you apply the right rule and don't make careless mistake, you will get the right answer. Question so far. Any question in terms of E, the answer is y to the 4. So let's attack F. And similarly, F, we know that we cannot distributive. If we distributive, we cannot distributive the 3 to the denominator because my parenthesis is only on the numerator. And once you distributive this item, for this particular problem, X and Y inside your parenthesis, you cannot add them together because the base are different. You cannot add the exponent if the base are different. And this is the only way you can do for F, is you get rid of your parenthesis. And if you get rid of your parentheses, do you agree that 7 times 3 to give me 21? 3 times 3 to give me 9. So my numerator, I will have x to the 21, y to the 9. Agree? And there's nothing we can do with the numerator. Even though it's multiplied, we cannot do anything because one of them is x, the other one is y. So what can we do? The only thing we can do is we can get the x together with the x and the y together with the y. And if we have this item, we know that we need to subtract them. Do you agree that 21 minus 14, that will give me x to the 7 left? And 9 minus 7, I get y to the 7 left. And again, x and y, they are not the same. We cannot combine them. Okay, and this is the answer. This answer will be acceptable. This answer will be good. If you want to impress me, well, you can't, right? Because your item is on my MATLAB, so I won't see your work, right? The reason is if I give you a paper, if you want to impress me, this answer is acceptable too. Just to show you that, do you agree that we can distribute the 7 in, and if we distribute the 7 in, that will give us that, right? So basically, you don't need to do this, but later on when we get to chapter 6, you will see that we can do this item. We can factor them out, for say. But for now, don't worry about it. Just know that if you have this item, the answer will be x to the 7, y to the 7. Okay. Don't worry about the x, y raised to the 7 power. Question. Question with this E or D. Pretty doable, right? Know your rule and apply your rule, right? Pretty doable. Now, when is not doable? Well, if you're looking at the previous 6 problem, we don't have any negative item, right? Of our previous six problem, we only have positive exponent. So things will look a little bit messy when you have a negative exponent. So for me, this is, like I mentioned, there are multiple ways to do this, and I will show you both ways. But I would tend to do one way a lot of time because I want to keep it consistent. Okay. So for me, this is what I tell my student is, if I have a negative exponent, just a negative exponent, if I have a negative exponent, is tell me that it does not belong there. So as you can see, this is anything as a whole number is on the numerator. Because of the negative exponent, everybody see that I can move my negative exponent to the denominator and change it to become positive. That's what negative exponent tell you to do. If you have a negative exponent, it does not belong there. If it's on the numerator, you move it to the denominator, or vice versa. If it's on the denominator, you move it to the numerator. So for me, I don't like to deal with negative exponent. So I move them, make it positive first. Because I know my rule that if it's division, what do we do? If it's division, all we need to do is we need to subtract. Agree? So in this case, we know that 7 minus 3, many of you guys jump to conclusion or jump into it and give me x to the 4. And that's correct, x raised to the 4 power. Okay, so that's one way you do it. And for me, I will keep it consistent and do it like that. But for those of you who say, Mr. Tran, can I say that if I have x to the 7 times x to the negative 3, can I say that 7 plus a negative 3? And surely you could, right? Because that's what the product tell me too. The product tell me that if I multiply, I need to add my exponent. And do you agree that instead of add the exponent, one of them is positive, the other one is negative? Well, because they have opposite sign, do you agree that we need to subtract this and keep the sign of the larger number? Agree? 7 plus a negative 3, 7 plus a negative 3 will give you 4. And just like before, you still get the same answer, x raised to the 4. But like I mentioned, I want to keep it consistent, and I will tell you guys to keep it consistent. If you have a negative exponent, it tell you that it does not belong there. So in this case, if you look at B, do you agree that if you look at B, the negative exponent is on the denominator? And if it's on the denominator, it tell me that it does not belong there. And if it doesn't belong there, do you agree that I can manipulate my item and I can move it to the numerator and it's become a multiplication, right? If it's on the denominator, I move to the numerator. And if I move to the numerator, it's become a positive exponent. And now, do you agree that after you did one operation, now it's just a simple problem because it's a multiplication. We know that we need to add them to give you y to the 12th power. So question with A or B here. Question of how I got x to the 4 in A and B, y to the 12th. Okay. And and whoever say, Mr. Tran, I did not do that. Yes, I understand. I know that you can literally do y to the 9 minus a negative 3. And again, what does the negative and a negative do? What does a negative and a double negative do? Well, a double negative become a positive, which is 9 plus 3, that will still give you 12. So regardless of how you do it, how you apply your rule, you still get the right answer if you apply the right rule. So let's take a look at C. How would we go about to simplify this item? First of all, we know that between Z and Y, we cannot combine anything because they are different base. So the only thing we have here, ladies and gentlemen, is we have a product raised into the power, right? So if we have a parenthesis, just like before, if we have a parenthesis, for me, I want you to get rid of that parenthesis by distributive, multiply them. And if you multiply them, do you agree that my Y is raised to the negative 6 because 3 times negative 2 is negative 6? And 4 times negative 2 will give me negative 8. Reminder, a power raised to the power, you multiply the 2 power, right? So everybody see where I still have to use that rule of sign, which is a negative times a positive, still a negative. So that's the one thing that a lot of you guys, dislike about this section is all of the rule that you learned before, the negative rule, the multiplication rule, all of the rule that you learned before, you still have to apply that on top of the new rule that you need to know, right? So is this my answer? Hopefully you guys say no, because they asked us this question. They asked us that our answer have to be in positive exponent. So both of them are negative exponent. Both of them are negative exponent. How can I make this negative exponent to become a positive exponent? Well, because it's on the numerator, do you agree that I need to move it to the denominator? And if I move it to the denominator, it's no longer a negative. But for me to illustrate, for me to show you that it's on the denominator and there's nothing on the numerator, I have to put the 1 to illustrate that the item that I have is on the denominator. Now everybody see that because of a negative exponent, because of the negative exponent, I need to move the negative exponent to the denominator since it's on the numerator. And that's my answer is 1 over y to the 6 z to the 8. Question with C. And if you don't have question with C, let's take a look at D. So D, what do we have? In the center of this item, similar to the previous material, if there's a parenthesis, for me, I want to keep it consistent. If there's a parenthesis, I want to get rid of the parenthesis by distributive the power in the parenthesis. And I have to be fair because there's 2, I need to distribute it to both of them. And when I distribute it, basically I take this number and multiply to my exponent, which is -3 times -5 to give me a positive, because a negative times a negative is a positive, which is x to a positive 15. And a negative times a positive will give me y to a -6. All over, I haven't done anything to the denominator, so my denominator stay the same. Everybody agree or question in terms of the first step, I distributed my -3 in by multiply them. And to make it consistent, because of this -6, I want to move it to the denominator because of that -6. Everybody see that I have x to the 15 all over x to the 4, y to the 4, y to the positive 6. Again, all I did was I took that -6 on the numerator, the exponent, and I moved to the denominator and it's become a positive. Everybody still with me here? Because the rule of negative, as long as there's a negative, is telling me it does not belong there. And if it does not belong there, I need to move it somewhere else, which is either on top or to the bottom. Okay. So once you have this thing here, hopefully you guys see that we have the x, and the x is divided. And if it's divided, we need to subtract the exponent. And if we subtract the exponent, do you agree that 15 minus 4 will give me x to the 11, and x to 11 will be on the numerator. This thing here on the denominator, so I have to still keep it on the denominator. I cannot move it to the numerator if it's on the denominator. Okay, one thing is don't move. The only time you move is when you subtract them or you use the product rule. But if it's on the denominator here, it's got to be, have to be still on the denominator. Okay, so in the sense, this will be my answer here, x to the 11 divided by y to the 10. Question with this item. Question with A, B, C, and D in the sense that we're dealing with a negative exponent. For C and D, there's no other way to do it. You have to get rid of your parenthesis and then apply whatever rule is left. Okay. All right. If you don't have question with those 4, let's take a look at the last 2 problem. And if you look at the last 2 problem, it look a little bit massive, right? So again, this 2, let's take a look at E first, and then we do F later. So for me, same thing go. If you look at this item and you can see the difference between this problem versus the other one is this item, we have a big parenthesis, meaning the parenthesis include every item we have. Okay, and for me, I want to, if there is a parenthesis, for me, I want to take this parenthesis, not parenthesis, I want to take this exponent and distribute it to every single item I have, because of this big parenthesis is have to distribute it to the numerator and the denominator. And if I distribute this item here, this is what I have. -2 times 3, this will give me x to the -6. Negative times a negative will give me a positive 14, and vice versa. Negative times a negative, this thing will give me a positive 8. Everybody see where my number come from? Again, all I did was I multiplied by 2 because the power rule tell me to multiply, and everything stayed the same, and I used the rule of sign to apply it. And like I mentioned, for me, because of this negative exponent, is tell me that it doesn't belong there. I need to move it to the denominator, and if I move to the denominator, I will have the numerator x to the 14 all over x to the positive 6 times x to the 8. Everybody see that how you get rid of your negative exponent. And from here, hopefully you guys see that all we got to do is on the denominator, because they multiply, I need to add the exponent. 6 plus 8 to give me 14. And do you agree that anything over itself is equal to what, ladies and gentlemen? 1. Thank you. Anything over itself is equal to 1. Or if you take a look at this item here, if you take a look at this item, do you agree that this is what they tell me to do, is take the numerator minus the denominator? 14 minus 14, what is 14 minus 14? Well, 14 minus 14 is equal to 0, which is x raised to the 0 power. X raised to the 0 power is equal to 1. So it doesn't matter which way you apply it. Anything over itself equal to 1, or the 0 power is equal to 1, you still end up with your answer 1. It's not x to the 1 power, it's just a constant 1. Okay, so make sure that this is, don't give them this on your homework. If you give them this on your homework, it will be wrong. Okay, so again, this thing here turned out to be a one whole number. Question in terms of E. So if you don't have question in E, what did I do? If you don't have question into E, let's take a look at F. And F is a little bit fun, right? They not that much fun. Similar to what we have in E, it's just that now, what do we do first? Hopefully you guys say we need to distributive. And again, from, it's weird. I know. For me, because I'm trying to show you how to do it. That's why I keep it consistent. Some of you guys, if you already know this, you guys probably do a little bit different. You can look at this thing here, and you can, if I do it in my head, I do it a little bit different than what I tell you to do. And just because I know my rule, and I can kind of maneuver my rule around, but because you don't, for now, you have not known, not understand, but remember your rule. So let's keep something consistent, redundant, or repetition, so that at least you know how to attack the problem when you see it. Okay, so when I see a parenthesis, for me to tell you, I distributive them in. And if I distributive them in, I just multiply this item to give me a negative 18, because 6 times 3. I multiply this thing here to give me a positive 9, because a negative times a negative will give me a positive 9. And all over a positive 21. So everybody see that a negative 7 times a negative 3 to give me a positive 21, negative 3 times negative 3 to give me a positive 9, and vice versa, a negative 18. And if you look at this item, after you did one sequence, after you apply one operation or one rule, the problem is just similar to E, right? We have a positive number, we have a negative number. So if we have a negative number, what do we do with that negative number? Well, for me, I want to get rid of the negative. I don't want to deal with a negative number. I move it to the denominator. And if I move it to the denominator, this is what I have, is z to the positive 18 times z to the 21. And once we have this item, do you agree that I have z to the 9 all over z to the 30 or 40. Agree? So ladies and gentlemen, looking at this.
39.
39, thank you, 39. 39. And look at this item right here, ladies and gentlemen. I want to give you a small advice. A small advice that help you a lot in the long run. You agree that because we have a division, and if it's division, do you agree that we need to subtract? Agree? A small remember. We know that this is what they tell us to do is we have to take 9 minus 39. That's what the division rule tells us to do. And 9 minus 39, that will give me a negative 30. And because the direction tell me that I need to write my answer in positive exponent, because of this is a negative exponent, is tell me that I need to move it to the denominator. And if I move it to the denominator, I need to show them or show you that it's got to be on the denominator. I need to put a 1 on top to illustrate that it's on the denominator. I mean, it's on the denominator, right? So looking at this item here, this is my answer. So one thing I want to point out to you guys or to show you guys that there's a shortcut is if we have a division, and in this case, you have a division. This is all you need to do is remember division, you need to subtract. And this is what you tell yourself is, which one have a bigger exponent? Is it 9 or 39? Since the 39 have a bigger exponent, when you subtract, the remainder going to be where the bigger exponent is at, okay? Do you agree that 39 take away 9 will give you 30? Right, 39 minus 9, that's 30. Where is the 39? Because the 39 is on the denominator. Because the 39 is on the denominator, therefore the 30, the remainder will be on the denominator. And how do I illustrate that it's on the denominator? Well, I just put a 1 because there's nothing left on the numerator. So in the sense of that, no matter what I give you, for instance, if I give you something like x to the 12 over x to the 8, you can see that 12 is bigger, right? 12 minus 8 to give you 4. But where is the 12? The 12 is on the numerator, so you just put the answer x to the 4 on the numerator. Everybody see that? Okay. I cannot move this thing over to write a 4. Just know that x to the 4 on the numerator. Okay, so that, that being said, if for instance you will run into this problem, something like this. Let me change the color. For instance, we have x to the 4, y to the 11, all over x to the 9, y to the 3rd. If you run into something like this, instead of just subtract them, do you see that we have to subtract them regardless, right? We have to subtract them regardless. And when you subtract them, just ask yourself, well, where is the bigger exponent? Do you agree that my x, the bigger exponent for my x is on the denominator? And what is 9 minus 4? Well, 9 minus 4, I know is equal to 5 because the 9 is bigger, it will be on the denominator. 11 minus 3 will give me 8 because the 11 is bigger, it's on the numerator. My answer will be on the numerator. So that's one way to kind of shortcut. Just look at your exponent, whichever have a bigger exponent. When you subtract whatever have a bigger exponent, that's where the remainder is going to be. And instead of say that, oh, we have a negative, and then you have to do that one extra step that you need to move to the denominator. Okay, so that's one way to shorten your problem if you want to look at that way. But again, question with E or F, or question, how did we apply the rule to the problem, or how your problem looked like in 5.1 and 5.5. Any question at all, ladies and gentlemen? Well, if you don't have